Hello, my name is Jiří Němeček, and with my co-authors we introduce Maximum Subgroup Discrepancy as a measure of bias. In case you're not aware, there have been numerous examples of algorithmic bias in practice. There have been systems that showed bias based on race, gender, immigrant status, age, or even social status. Importantly, the bias against one protected group can compound when considering an intersection of groups, as shown by the work Gender Shades by Joy Buolamwini and others. However, intersectional bias can be present even when marginal fairness is achieved. Imagine this example dataset, where the green check marks represent a positive class, say acceptance, while red crosses mean rejection. In this case, each group has the same proportion of positively classified samples, meaning that there is no marginal bias. However, looking at this cell, we see that blue persons younger than 18 are all rejected. Such intersectional bias is undetected by statistical parity. This is where maximum subgroup discrepancy comes in. It finds the most misrepresented subgroup, comparing examples from the two distributions. In this case, the positive and negative samples. MSD then returns the subgroup together with the discrepancy value. Compared to most other distributional distances, MSD has linear sample complexity rather than exponential. Additionally, unlike some other detectors of intersectional bias, MSD returns an interpretable subgroup in its natural form. We also guarantee to find the most discrepant subgroup out of all subgroups. And last but not least, our implementation can handle practical dataset sizes. I hope you're intrigued, and if so, you can read our paper via the QR code on the left, or use the MSD through the QR code on the right. Thanks for listening.